Bismillahirrahmanirrahim. I welcome you all in AppSex Online Sport and Assignments tutorial for Round 2 Week 3. I am Zubia Razak from APS Chaktamni. The grade is 7 and subject is Science. Recipe is chapter number 4, Water and Sound Waves. Task 1, that is about waves and types of waves. Waves carry energy from one place to another without any matter being transferred. There are three main types of waves: water waves, sound waves, and light waves. Water waves move energy across water. Sound waves move through the air to vibrate our eardrums so we can hear. And light waves travel through the surface to illuminate things so we can see them. Water waves are if you throw a pebble into a pond, ripples spread out from where the pebble went in. These ripples are waves traveling across the surface of water. Water waves are transverse waves. This means they move up and down or oscillate at right angles to the direction of travel. Transverse waves can be modeled with a spring called a slinky. As each coil in the spring oscillates, it causes the coil next to it to oscillate a fraction of a second later, and so on, producing a moving wave effect. So here is a wave, here is crest, which is the highest point of this wave, here is trough, which is the lowest point of this wave, here is the midpoint. Amplitude is the distance between the peak of the wave and the midpoint, and wavelength is the distance between two adjacent troughs or two adjacent crests. Frequency is the number of waves per second measured in hertz. 1 hertz is equal to 1 wave per second, and period is the time between one wave peak and the next. I have discussed about all the content that is asked in question number 1 to 5 of Test Yourself page 54. These are home tasks for the day 1. Task 2. Features of water waves. Water waves can reflect or bounce off a flat barrier. Waves are reflected at the same angle as they hit the barrier surface. So here waves are coming and here they are reflecting back at the same angle when they are hitting a flat barrier. Did you know that water waves slow down and the wavelength shortens when they reach shallower water? This is refraction. If waves strike a shallow area at an angle, they change their direction, as you can watch in this picture. So this is refraction. But here the water waves are spreading when they are passing through a gap. So this is diffraction. When waves meet, they can interfere with each other. If two waves meet with peaks matching peaks, they add together and produced much higher wave with greater amplitude, as in this picture. This is constructive interference. And here there is no wave, so it would be destructive interference. If two waves meet each other with peaks matching troughs, they cancel each other and produce a wave with no amplitude. There is no wave. This is destructive interference. So here it is destructive interference and here it is constructive interference. You have to do exercise question 3 and 4, in which the diagram shows water waves moving towards a sea level. The questions are: what will happen to the water waves when they strike the sea wall at A? What will happen when they strike the sea wall at B, and what will happen to the water waves when they pass over shallow water at sea. So you have to write the answers of these questions by your own. Explain why this happens. Describe what would happen to the waves if a narrow gap appeared in the harbor wall. Explain why this happens. So I have discussed all about refraction and diffraction earlier. Next is the diagram shows a wave as seen on the screen of an oscilloscope. You have to mark the wavelength, amplitude, and the sound waves in the diagram represents 4 vibrations. It was created in 1 by 10th of a second. What is the frequency of this sound in hertz? I have discussed before. So you have to solve these questions by your own. These are the home tasks for the day 2. That was all about waves, frequency, amplitude, wavelength, refraction and diffraction. Thank you and have a nice day.